Hi, so for today we're going to talk about polynomials, and this is a continuation of our study about the intervention for calculus, okay, drafting. So last time we have discussed real numbers, so make sure to watch it also. And this is my very second video about intervention for calculus. So today we're going to talk about polynomials. So what are polynomials? No? So basically, polynomials are composed of uh, different, okay, combination of the coefficient and what we call the variables, okay, with the operators plus, minus, okay, in the polynomials, of which, okay, the variable such as x has some degree, okay, or the x is raised to a certain number of n, which we call degree. So the highest power of the variable that occurs in the polynomial is called the degree of a polynomial. Okay? So the highest number that is appearing on the power of a certain variable is called the degree of a polynomial. And we also have the terms the leading term and the leading coefficient. So the difference between the two is that we have the leading term is the term with the highest power, that is. So that is the highest power, and its coefficient is called the leading coefficient. So as we can see, we can represent polynomials in this form. We have a sub n multiplied by x raised to n plus ellipses up until we have a sub 2, a sub 1, and a sub 0. So a sub 0, constant, denotes the constant, okay? And the variables a sub n, a sub 2, and a sub 1 also denotes the coefficients of the polynomials, okay, of the every term of x in the polynomial. So for example, we have x squared plus 2x plus 1. Okay, we have a degree of 2, okay, and the leading term is x squared, and the leading coefficient, which means the coefficient of the highest degree in the term, is 1. So the leading coefficient here is 1. Okay? So basically, polynomials has many forms, okay? For example, you have 2x cubed minus 3x minus x plus 1. So again, the degree of this polynomial is third degree. The leading term is 2x cubed since it contains the highest degree, okay, among the terms. And the leading coefficient is basically 2. Alright? So that is for the polynomials. And we will be seeing polynomials all throughout the discussion of this because this is intervention for calculus. So identifying the degree and leading coefficient of a polynomial. So let's try. So you have 3 plus 2x squared minus 4x cubed. So this is 4x cubed. Let me just rewrite. So you have minus 4x cubed. Okay. First, we have to identify the degree. Okay, and then we have the leading coefficient. So for the very first one, we have the degree of the highest appearing is 3. So we have 2 here. Okay. So the highest appearing is 3. So this is a third degree polynomial, degree of 3. And the leading coefficient, okay, or the leading term is negative 4x cubed, of which that is the term that has the highest degree. Okay. And the leading coefficient is, of course, the negative 4. Okay. So for letter B, we have 5t raised to 5 minus 2t cubed plus 7t. Okay, so the degree here, highest appearing is 5, obviously. So you have, this is a degree of 5 or the fifth degree. And this is the leading term, 5t raised to 5. And the leading coefficient is the coefficient of the leading term. So meaning that's 5. Okay? And lastly, for letter C, we have 6p minus p cubed minus 2. So what we have here is we have a cube here. That's very sure. So you have a third degree or degree of 3. And the leading coefficient, what is the coefficient of negative p cubed? As we all know, we have negative 1 here. So we are going to write negative 1 here. So that's the degree and the leading coefficients identified in the polynomials. So we can also perform operations in polynomials. And operations in polynomials involves addition, subtraction, multiplication, and division. So, in addition and subtraction, given multiple polynomials, add or subtract them to simplify the expressions. And here are the two basic steps. You have to combine the like terms when you are adding or subtracting, and you're going to simplify it and write it in standard form. So for example, in letter A, find the sum of 12x squared plus 9x minus 21. Okay, and then plus, you have 4x cubed plus 8x squared minus 5x plus 20. So, the meaning of this is that we combine like terms. Is that we are going to combine terms, okay, that are alike. For example, 12x squared and 8x squared. Okay? 9x with minus 5x. And the negative 21 and 20, because they are both constants. So in other words, I can add them. You have 12x squared here plus 8x squared. You try to find another x squared in the polynomial. So there's none. So you now move on to x. So you have plus 9x. Do you have any x here as the variable? Yes, we have negative 5x. So positive becomes negative because of plus of negative 5. So this becomes negative 5x. So 9x minus 5x because of the negative here. Or even though it's plus. Because if we distribute the positive sign, still this will be negative. And also we have negative 21 plus 20. And we have another degree here, 4x cubed, which has no like terms in the polynomial, so we're going to copy it, 4x cubed. And then we simplify. 12x squared plus 8x squared is 20x squared. 9x minus 5x would be 4x. Negative 21 plus 20 would be negative 1, and then we copy 4x cubed. So it is best practice to write first to the highest degree, okay, down to the lowest degree. So we can rewrite the answer as 4x cubed plus 20x squared, okay? And then we have minus 4x minus 1. So this will be our final answer in just adding these two polynomials. So moving on to letter B. If we move to letter B, we have 2x cubed plus 5x squared minus x plus 1. And they have plus 2x squared minus 3x minus 4. Alright? 3x minus 4. So you have to combine like terms. Do we have x cubed on the other side? We don't have. So we can copy 2x cubed. Then we have x squared. Do we have x squared? We have plus 2x squared here. Combine it. Do we have any x squared? None. So let's move on to negative x or x. So you have negative x. You have minus here, minus 3x, so combining like terms. And then you have positive 1. Combine it with the constant minus 4. So again, we perform. 2x cubed is as is because we don't have anything to add to it because we don't have any x cubed in the polynomial. 5 plus 2x squared. So you have 5x squared plus 2x squared is 7x squared. Minus x minus 3. Okay? Minus x minus 3, this will add negatively. So, but negative 4x. And then plus 1 minus 4 would be negative 3. Okay, so that's how simple we add the two polynomials. Now, for letter C, let us try for letter C. Okay, so you have 7x raised to 4 minus x squared plus 6x plus 1. Then you have minus 5x cubed minus 2x squared plus 3x plus 2. So what are we going to do here if we encounter such subtraction? We are going to distribute the negative sign on each of the term, okay, in this one. So don't forget that, to distribute the sign, and then you proceed to addition. So if I distribute that, that would be negative 5x cubed Negative times negative would be positive 2x squared. Negative times positive would be negative 3x. Negative times positive 2 would be negative 2. Okay? So we can freely 7x raised to 4 minus x squared plus 6x plus 1. Write this. Minus 5x cubed plus 2x squared minus 3x minus 2. So combining like terms. So we don't have terms for 7x raised to 4. So we copy it as it is. Okay. Do we have for x cubed? It's negative 5x cubed only. Okay. Do we have for x squared? We have negative x squared plus 2x squared. So negative x squared plus 2x squared will become plus x squared. Or 1x squared. Positive 1. So you have 6x. Do you have 3x here? So 6x minus 3x here will become positive 3x. And finally, you have the constant plus 1 minus 2, and that is negative 1. So this will be your final answer for this subtraction of polynomials. Okay, how about multiplying the polynomials? So given the multiplication of two polynomials, we are going to use the distributive property to simplify the expression. So we are going to multiply each term of the polynomial by the term of each term of the second. So combining like terms, and then we're going to simplify. So for example, we have for letter A 2x plus 1 times 3x squared minus x plus 4. So simply what we are going to do is this. So you have 2x plus 1. Now you have 3x, multiplied it by 3x squared minus x plus 4. Utilize the distributive property. So I'm going to distribute this first, distribute this to this, and distribute this to this. And after distributing, I'm going to distribute positive 1 on all of the terms also. Okay, so first, we distribute for 2x. So we have 2x times 3x squared. Okay, and then we have plus 2x times negative x. Okay, then we have plus 2x times positive 4. And then, second term times 1. So we have plus 1 times 3x squared. Okay, this is that. Okay. And then what? Plus times 1, negative x, and then plus 1 times 4. Okay? Considering the signs. I've added plus, okay, for the simplification of our whenever we try to multiply polynomials. Okay? So we have 2x times 3x squared. We have 6. We're going to add the exponents because it is multiplied. So x raised to 1, and then x squared, that would be x cubed. Next, we have 2x times negative x. That would be negative 2x squared. So negative times positive would be negative. And this plus becomes negative because negative times positive would be negative. So next, we have 2x times 4, 8x. So this becomes positive 8x. And 1 times 3x squared, obviously 3x squared. 1 times negative x becomes negative x. 1 times 4 would become positive 4. Okay? So simplify. Combining like terms. Do we have cube? We don't have. Do we have x squared? That is negative 2x squared plus 3x squared. That would be positive x squared. Do we have for x? 8x minus x. That would be positive 7x. And lastly, we don't have any for the constant to simplify. So we just simply copy plus 4. Alright. So for letter B, what are we going to do is the same. Distribute this 3x to all of the terms. So let's try. So you have 3x times x cubed plus you have 3x times negative 4x squared plus you have 3x times 7. Okay? And then for the 2, we have plus 2 times x cubed plus 2 minus 4x squared plus 2 multiplied by 7. Okay, so simplify. You have 3x times x cubed. That would be 3x raised to 4. Remember, we are multiplying x to x cubed. So, the exponent will add. And then 3x minus 4x squared, that is negative 12x cubed. 3x times 7, that would be positive 21x. 2 times x cubed, that would be 2x cubed. 2 times negative 4, that would be negative 8x squared. Then 2 times 7, that would be 14. Combining like terms. So for 4, x raised to 4, we don't have anything to combine. Okay? So you have to copy 3x raised to 4. Okay, for cube, do we have negative 12 plus 2x cubed? So we have, so negative 12x cubed plus 2x cubed would be negative 10x cubed. Okay, how about for squared? We don't have for any squared, so we copy negative 8x squared. And for x, we don't have for x, so copy 21x. And for constant, we only have 14, so you copy plus 14. So this will be your final answer in multiplying 3x plus 2 and x cubed minus 4x squared, okay, plus 7. Alright? So how about the FOIL method? Okay, there is what we call the FOIL method. There is what we call a shortcut. Okay, sometimes it is called shortcut or FOIL method, used to find the product of two binomials. So binomials meaning we have a plus b and multiplied by c plus d. Okay, so these two are binomials. Example of binomials, you have x plus 1, then you have x plus 2. Or it can be 2x plus 1 and then 3x minus 2. Okay? These are all binomials, meaning two terms. So you have the first term and then we have the second term. So it's called binomials. Irregardless of their exponent, still these two are binomial, even though it has squared here. Okay? So the term FOIL stands for the first terms multiplied, the outer terms, which are this. The first term are this. The outer are the outer parts. The inner are this. And the last term represents the last term for the first and the last term for the second. So these are all multiplications. Okay, and then simplify, okay, in order for you to get the answer. So how about we try this? X plus 7 and 3x minus 5. We go for the FOIL method because these are both binomial, meaning two terms contained in the polynomial. So you have first x times 3x plus outer x times negative 5. So don't forget to include the sign, okay, including here. That's the outer. And the inner is positive 7 times 3x. And finally, the last would be 7 times negative 5. The last of the first term and the last of the second term. So we have plus 7 times negative 5. So you have 3x squared minus 5x. 7 times 3, that would be 21x. 7 times negative 5, that would be negative 35. So simplify. We have 3x squared. No common terms or combining like terms. So you have negative 5x plus 21x. So that will result to a positive 16x minus 35. So that will be your final answer for this FOIL problem. Okay? So you can do this. You can do this anytime we have two binomials, okay, being multiplied. Again, I repeat, only binomials that are being multiplied. Okay? So we also have what we call perfect square trinomial. So which means that we have a binomial that is squared, it becomes a perfect square trinomial only if we can write it in the form of this. Okay? Wherein we have a plus b raised to squared, wherein we have a squared plus 2ab plus b squared. Okay? That's a perfect square trinomial. So just like this, you have x plus 5 squared. Okay? If you realize this is just simply x plus 5 times x plus 5. So meaning, perfect square trinomial or PST only happens when we have two binomials being multiplied to each other that are exactly the same. Okay, for example, x plus 5 and x plus 5, that is an example of a perfect square trinomial. You have x minus 3 squared, that is still x minus 3 times x minus 3, that is an example of perfect square trinomial. And we also have 4x minus 1, so that is 4x minus 1 times 4x minus 1. So exactly the same two binomials being multiplied to each other forms a what we call a perfect square trinomial. Okay? And I have a you can still use the FOIL method, okay, to get the result. Let's say we have x plus 5 times x plus 5, okay? So first, x times x would be x squared. Outer for letter O, x times 5 would be 5x. Inner is x times 5 also, which is 5x. And the last would be 5 times 5, which would be 25. So you have x squared, 5x plus 5x would be 10x plus 25. And hence, we arrive at this answer. Okay? So if you do the FOIL, you will also arrive at the same answer. But I can teach you that whenever we have perfect square trinomial, okay, you can have it as shortcut as it is. So we know that if that is a perfect square trinomial, it will produce It will produce three terms, hence called trinomial. So the very first thing is you're going to square the first term, that is x squared, and the second term will be solved by multiplying all of the terms. So you have x times 5, that is 5x, and then multiply by 2, multiply it by 2, not raised, multiply it by 2, 5x times 2, that would be positive 10x. And for the last term, you just square the last term. So 5 square would be 25. So that will be the answer. Still the same. Alright? So, and hence we got this formula here. That is the same formula that I use in order to get mentally, okay, the result for the binomial that is squared. So, expanding the perfect squares. So, we can do this in two ways. So, we can use FOIL, 3x minus 8, and then 3x minus 8. Okay, I'll use this first. So, you have first 3x times 3x. Okay, we have outer plus 3x minus 8. You always write plus. Okay, inner is negative 8 times 3x. So, you negative 8 times 3x. And then last, we have negative 8 times negative 8. So, you have negative 8 times negative 8. So, you have 3x times 3x, that's 9x squared. Negative 8 times 3x would be negative 24x. Negative 8 times 3x, still negative 24x. Negative 8 times negative 8 would be positive 64. Negative times negative would be positive. So, simplifying, you have 9x squared minus 24x minus 24x will be adding negatively. So, you have negative 48x plus 64. So, this is the expansion of that perfect squares. Or, what I've told you a while ago, you have 3x minus 8 squared. First, you have to square the first term. 3x squared. Okay? And then plus, you're going to multiply all the second or all the terms. So you have 3x times negative 8 and then times 2. Okay? And then lastly, we are going to square the last term. So the result would be 9x squared. Okay, we have negative 8 times 2, negative 16. Negative 16 times 3x, that is negative 48x. And then negative 8 squared would be positive 64. Because negative 8 times negative 8 would be positive. And it is the same answer that we got here. Okay? So for letter B, we have 4x minus 1 squared. So let's do the same. So you have to square 4x plus, you have to multiply all of the terms. So you have 4x times negative 1 times 2. Okay? Don't forget the times 2 because of this. It's not squared, it's 2 in the formula a while ago. It's times 2 here. Okay? And then plus squared the last term. So you have negative 1 squared. So you have 4x squared would be 16x squared. 4 times 4, 16. And then we have 2 times negative 1 is negative 2 times 4x. That's negative 8x. And then negative 1 squared would be positive 1. So this will be your expansion of the perfect square trinomial. Okay? So if you do the FOIL, it's still going to be the same. Okay? The answer will be the same. So we also have difference of squares, wherein another special product is called the difference of square. Wherein, okay, the only difference, for example, we have two polynomials or two binomials being multiplied. The only difference is that the first term has a plus and the second term has a negative. And therefore, if we have this type of, let's say, difference of squares, it's just simply reduced to a squared minus b squared. Okay? The result will be a squared minus b squared. So let's try to solve it. Okay? So again, we have a plus b. We have a minus b. The result would be still a squared minus b squared. And this is called the difference of squares. So how about for this? 9x plus 4 and then 9x minus 4. If you're going to notice, the difference is only the sign. But the a and the b's are the same. Okay? It's just about the sign. Okay? So, we expect that if we multiply it by FOIL, we will still be arriving at the same answer as this. So, why don't we try 9x squared minus, we have 4 as our b. We have 4 squared. So, 9x squared would be 81x squared minus 16. Alright? So, if you don't believe me, let's do that in FOIL. 9x plus 4 times 9x minus 4. So, you have 9x times 9x. That would be 81x squared. Outer would be negative 36x because 9x times negative 4. 9, 18, 27, 36. And the inner would be 4 times 9x, which is plus 36x. And then the last would be positive 4 times negative 4. That's negative 16. So as you can see, 81x squared, negative 36 plus 36 would be simply 0. We have negative 16 here. So that's the answer. Because it is the difference of two squares. So for letter B, we have 2x plus 7 and 2x minus 7. So what are we going to do? Okay? So first, we square 2x. Then minus, we have square the 7. So you have 4x squared minus 49 because 7 times 7 is 49. Alright, so that is the difference of squares. Okay, so how about performing operations with polynomials of several variables? So for example, we already have different variables. So far in what we are studying, okay, we only have x, right? That's our variable. What if there is another variable, let's say a, b, c? Okay? The rules are still the same, okay? But we cannot just simply add a and b because a and b are different variables. So is x and y. So we cannot just say x plus y will be equal to 2xy. That is not the thing. X is different from the variable y, and they may not have the same value. So take a look at this example. So we have a to b. Okay, we have a plus 2b. We have 4a minus b minus c. Distributive. So still distribute. So you have a times 4a plus you have a times negative b you have a times negative c. And going to the second term, 2b times 4a plus 2b times you have 4a. And then you have 2b minus b. 2b minus b. And then you have 2b times negative c plus 2b times negative c. Simplify. So, a times 4a, that is 4a squared. A times negative b, that would be negative ab. Okay? So, simply we just multiply them with the sign. And then a times negative c would be negative ac. 2b times 4a would be positive what? 8ab. Okay, only the coefficients will be successfully multiplied. But the AB, we write it AB, as multiplied. So you have 2B and negative B, that is negative 2B squared because of the negative here. And 2B times negative C, that would be negative 2BC. Alright? So, combining like terms. So you have 4A squared. Do you have A squared only? No. Okay? So, basically, we have negative AB and positive AB. Same variable, same term. So, negative AB plus 8AB would be plus 7AB. Okay? So, you also have, okay, negative AC. So, you don't have any negative AC. So, we write negative AC. Okay, we don't have also negative 2BC to combine with. So, we write it. And lastly, we have negative 2b squared. No like terms, so you have to write it. Okay, so this will be our final answer. Alright, so that's how you multiply or perform operations including several variables of the polynomial. So, and that's all. I hope you enjoyed this video. I hope you learned something from the polynomials. If you want me to do more examples about this, let me know in the comment section below and by clicking the like button. So if there is enough request, I will continue to have more examples for this. And again, this is Jei Abat. So for you to learn more, okay, about intervention for calculus and calculus 1, calculus 2, differential equations, advanced math, and many more engineering subjects, please don't forget to check out my playlist. I have playlists in algebra, calculus, differential equations, advanced math, statics, dynamics, okay, electronics, communications, etc. So, I hope you like this video and see you again on the next video. Bye!